cyclohexane conformation. After completion of this presentation, you are able to clear different types of conformations of cyclohexane. So first of all, the cyclohexane is a 6-membered saturated ring system, and all carbons are sp3 hybridized. These all bonds must create 109 bond angle. This leads to types of conformations in 3D, that is boat shape and chair shape of conformation. So this is a cyclohexane structure. It does not have any angle strain. It is not a flat molecule. By rotating about carbon-carbon bonds, it can achieve 109.5 degree bond angle. It is a normal bond angle by rotating carbon-carbon single bond to form this puckered ring system. When these bonds are rotated, this single bond, carbon-carbon single bonds are rotated to form this chair conformation. This is having normal angle, tetrahedral angle is 109.5 degree. This is again cyclohexane. This carbon is having two bonds, one is axial, another one is equatorial bond. This blue color indicates the equatorial bond and this black color is axial position in the chair conformation. This is the equatorial position in the chair conformation. These are the different forms of cyclohexane. One is chair, this one is twist boat and boat conformation. Representation of cyclohexane in chair, twist boat and boat conformation. This chair conformation, this axial carbon hydrogen bond, this is red color indicates this, all brown color or red color, these are the axial bonds, these are the equatorial bonds. Hydrogens are in the equatorial position. This is axial and equatorial bonds together structure. Representation of axial and equatorial bonds of cyclohexane in puckered ring system. The chair conformation of cyclohexane is free of both angle strain and torsional strain, that is a deviation from the staggered. Thus, this is the most stable conformation. One reason is that the chair conformation is more stable than boat conformation because this cyclohexane chair conformation is free of both angle strain and torsional strain, and it is deviate from the staggered conformation. It is represented by Newman projection of the cyclohexane. It is more stable than boat conformation. We will see in the next slide. In the boat conformation is free of angle strain but has a great deal of torsional strain. It is eclipse. These are the eclipse one, back to each other. To relieve the strain, it twists slightly to form twist boat. To relieve this strain, to form a twist boat conformation, means boat conformation is less stable than chair conformation, but this twist boat is more stable than boat conformation slightly. By twisting this carbons. Conformational analysis of the cyclohexane. Chair form is more stable form because it forms a tetrahedral bond angle 109.5 degree. It adopts staggered arrangement. All this makes chair conformation with least torsional strain than other isomers. Torsional strain and bond angle is also least in case of chair conformation. This is the staggered arrangement of bonds in chair form. Staggered arrangement. This is in the form of Newman projection. It will be represented better than this chair. In case of boat conformation, there is a flag-pull interaction between these two hydrogen atoms of carbon number 1 and carbon number 4. 1, 2, 3, 4. Isn't it? These are the flag-pull interaction with each other. That's why this boat conformation is least stable than chain conformation. When we twist these two carbons are twisted, these hydrogens are away from each other. So this twist boat conformation is generated, which is more stable than this boat but less stable than this chair conformation. So twist boat and half chair conformation. Twist boat is twisting of the boat result in a release or in a steric strain due to flagpole interaction. This will be twisted. These bonds are twisted, carbon carbon, so these are away from each other. And half chair conformation, in if carbon 1 and carbon 4 of chair conformation is brought in average plane of the ring, these are in the plane of ring, this is a 4 and this one is 1 number carbon, the resulting conformation is called as a half chair conformation. Correct. When this is above the plane and this one is in the plane, this means this 5 are in the plane, 1 is above the plane only, this is called as half chair conformation. The squeezed boat is also called as a squee boat conformation by twisting this carbon 1 and carbon 4. That is a less torsional strain as compared to boat conformation, that is flagpole as are away from each other as we discussed in the last one, and carbon number C2, 3, 5 and 6 become a non-planar. The energy content is 6.6 kilojoule less than boat, that is, but 23.02 kilojoule more than chair. That's why this is least stable than chair conformation. Therefore, it is more stable than boat but less stable than the chair conformation. So, conformational analysis of the cyclohexane, relative stabilities of conformations are shown in this diagram. This is chair conformation A having the 0 kilojoule energy. When we shifted to this in the half chair means if it is 1 is above the plane and these rays are in the same plane, this is half chair conformation. Again we shift this into twist boat, means these are away from each other. Boat means 1 and 4 are in the same plane, and 4, 2, 3, 1, 2, 3, 2, 3, 5 and 6 are in the same plane, that is boat conformation. And when we twist this, it is least energy, having more stable than this boat again, that is again half chair. When this ring A is flips to ring B by the converting this half chair, these are the intermediates of this conversion of one ring to another ring, means chair A is converted into chair B. When in case of chair A, it is carbon number 1 is above the plane, so in case of this chair B, 1 number carbon is below the plane. When we change the ring from 1A to B, it is called as ring inversion, and the axial bonds become equatorial and equatorial bond becomes axial when the ring is flips into each other. These are the relative energies of this chair is neatly 0, like this more stable, this is 0. Then boat conformation 25 kilojoule, that is 25 kilojoule, this one. Then 43 kilojoule per mole, it is half chair, it is 43 kilojoule per mole. Then 21 kilojoule per mole twist boat, that's 20. That's why this chair is more stable than twist boat, and or it is called as skew boat, and this is more stable than boat, which is more stable than half chair, means the half chair is the least stable conformation of cyclohexane. The boat form can be obtained from the chair conformer by bending the bonds. During transformation, two other forms arise, that is half chair and twist boat. When one ring flips to another ring, one A ring chair conformation is converted into B chair conversion, is called as ring inversion or ring flipping. This is regarding means conformations of cyclohexane. Out of this 4 conformations, chair is the most stable conformer of cyclohexane, than twist boat, which is more stable than boat, and boat is more stable than half chair, and half chair is the least stable conformer of cyclohexane. The substituted cyclohexane, consider this only methyl cyclohexane. Then mono-substituted cyclohexane has a 2 equivalent chair conformation, A and B chair. The 2 chair conformers of mono-substituted cyclohexane as methyl cyclohexane are not equivalence. The methyl substituent is in the equatorial position in one conformer and in axial position in other conformer. This is methyl group is equatorial, this one is axial position. It is less stable than this axial. Why? Because this is 1,3 diaxial interaction. We will see in this. Because of the substituent has more space, are less hindered and therefore fewer steric interaction when it is in the equatorial position. You see this. This one is the 1,3 diaxial interaction. This is called as 1,3 diaxial interaction. That's why this axially is least stable than equatorial. There is, because of the interacting substituents are on the 1,3 position relative to each other, these unfavorable steric interactions are called as 1,3 diaxial interaction. In contrast, when the methyl group is in the axial position, there are unfavorable steric interaction again between axial and methyl groups, and both the axial substituent on carbon 3 and carbon 5 of the hydrogens are, this is called as 1,3 diaxial interaction. That's why axial methyl cyclohexane, axial position, this is least stable than equatorial methyl cyclohexane due to this 1,3 diaxial interactions of each other. Thank you.